So this is a very simple Angular application where I'm having here two components. They are already registered within our ng module. And let's go back here to our app component HTML and quickly instantiate both of them. And so you can see they get rendered on the page correctly. Now assume these represent different kind of states our application might be in. So when the user navigates to the home part of our application, we want to show this component. When he wants to get information about our application, we want to show this component. Now, obviously we could do this with some kind of if statements and then switch the components on and off, but that is obviously not scalable when our application gets more and more components. Rather, what we want to do is to use the routing mechanism. So we have the router already installed. The first step is to import a router module directly from Angular's router package. Next, we can go down here in the module section and use the router module.forRoute, where we then register different kind of routes. Now, obviously those routes need to be defined. So let's create here an array. Let's also import here the correct types, always from the router package, and define our first route. So let's say whenever the user navigates to home, we want to show the home component. So as you can see here, I am defining here the path, which defines the URL, which the router has to verify. And once the URL is matched, he should activate this component. Similarly, whenever the user navigates to the about, we want to show the about component. Now let's save this. We also need to reference these routes here in the router module configuration. So from that point of view, the setup is done. We need to do a final part, which is to go in our app component and specify where those dynamic routing components should be inserted. And for that purpose, we can use the router outlet. Great. So now when we change the URL to go to home, you can see that the home component gets activated. And in fact, if we inspect here, we can see here the router outlet, and just below the router outlet, the component will get inserted by the router dynamically. Similarly, if we change to about, the about component gets inserted dynamically below the router outlet. So in our sample application here, we have defined a couple of routes, which we have registered to the router modules for route method. Now, if we refresh our application, we can see that none of our components gets actually shown. So they only get loaded if we navigate directly to the about route or to the home route. What we would rather like to have is that whenever we come to the root of our application, it automatically redirects to our home route. Now, in order to achieve this, we can specify a redirect route. First of all, we define here the path, which will be the empty string. And in order to defining a component here, we can use the redirect to property and specify home. There's another thing we need to do here, which is to define a path matching strategy, which in this case will be full. Now the default is prefix. What prefix means is that Angular is going to analyze the route here and match it incrementally. The problem is that whenever we have another route down below, it will never go and actually invoke that route, because every route starts with an empty string, and therefore always this route here will be matched. Now if we specify the full matching strategy, this means that this route will only be matched if the route is completely empty. So it matches 100% this definition here. Now let's actually save this and test whether this works. Let's remove the route definition up there. And as you can see, it properly redirects now to our home route. So in this sample application, we have defined different kind of routes, which we can navigate to by changing the URL up here. Now what happens if the user types in some URL which doesn't exist? Now our application redirects simply to the home and nothing happens. We want obviously to have a better user experience. So let's generate a new component. Let's call it not found. And then we go to our app module, and at the very end here, we define a route which is going to catch all those routes which aren't matched. And we do that by defining here two asterisks. And as the component, as you can imagine, we specify our not found component. Let's open the not found component. Specify here, sorry, nothing to see here. Great, let's save this. Now whenever we go to our routing component here, our normal routes just work, and whenever we specify a route which doesn't exist, our component here, not found, gets loaded and displays something nice to the user. So in our neat little application here, we have defined a couple of routes, which you can see here defined in this array here. And those are being registered then down here in the router module for route and the app module. Now, what jumps to one's eye immediately is when you look at the route configuration, we have here two components, one in the people module and one in the contacts module. And both components reside inside separate dedicated modules which follow the normal pattern of how you structure Angular applications. So they have their own ng module where they define their components. Now, similarly, we will also like to structure our routes. As you can imagine, in a more complex application, this route definition here might get quite complex and quite huge and turns into being very hard to maintain and to manage. So therefore, one suggestion which has to be taken for sure is to externalize this in its own file and manage it there. But anyways, it would be much cleaner to further split those out into their own modules. And this is exactly what the routing module pattern suggests, which is one of the patterns that should be followed according to the official Angular documentation. So let's take a look how this works. So let's start with the people module here, and let's simply define a new file, which we call people-routing.module. Now this file is a normal ng module, so we need to import the ng module from Angular core, and then we define the ng module section below here. And we also export it. We call it people routing module. So this follows the official style guide on Angular.io. Now next we need to define our routes, obviously. So we can go back to the app module and copy out that person route which is defined inside here. So let's remove it from here for a second. Jump back to our people routing module, and here we define our routes, which is an array which defines here our people component. Obviously, we need to import that as well. And once we have that, we can then import the routing module. So import the router module from Angular router, and then we can go down into the ng module section. And then in the imports part, we basically declare the router module dot. And this time we don't call for root as we did in the global router part, but this time we define for child and we pass in the routes definitions. So last step, we also need to export the router module such that it can be then consumed by others. So once we have defined the people routing module, we obviously also need to register it on its own people module. And that happens directly in the import section. So here we define the people routing module when you import it from where we have defined it. So we need to do the exact same also for the contacts part. So let me just quickly do that for you. Great. So once we have both modules here defined, so the contacts routing module as well as the people routing module, we can go back to our app module and do the very same thing also for the application itself. So we take out those definitions, we create its own file, app routing module. Here we need to import the very same things. Then we can copy in here our route definitions. We also need obviously to import the components. So the home component here, the about component, and the not found component. All of them belong to the global app module. As you can see, they got import directly from the local directory. And then finally, we need to also register them. And here you have to pay attention because now we have to define obviously for route and pass in those routes definitions. Great, so we have concluded most of the parts. We need to finally jump back to our app module. We can remove here parts like the contact list component and the people detail component, as we haven't really registered them here because they have their own registrations in their modules. What we need to do here is to import app routing module. And then finally we have to register all of them down here. So the people module and the contacts module have already been registered. And here we need to define the app routing module as the last part. The sequence here is very important. Now each of these defines their own child routing modules, which have to be defined before, and then at the very last comes the app routing module. Because as we know, the routings are being processed by sequence, and so therefore moving around these could have some strange side effects. And now if we save and refresh here the browser, you can see that the home route perfectly loads. We can then also go to the contacts list, and the contact list works, and also the people person detail works as we expect. So we have here a very simple route defined here in our people routing module. And whenever we point our browser's URL bar to this path here, we get the person detail component here visualized. Now what we would like to look at now is how we can add variable parts to that route, which help us transport data in our URL. Now one way to do that is by using so-called router parameters. And you can define them by starting with a colon and then by giving them some kind of name like ID or also person ID. Now in this example here, this could be basically from the whole list of people, show me the person with that kind of ID. Now this is just the first step, basically to define that variable part. The next step is then to go into our person detail component and to actually read that information in order to display the person that matches that ID onto our component. So the first step here is to get a hold of an instance of the activated route. So let's inject that here. And we need to import that from the Angular router here. And then within our constructor here or directly within our ng on init, we can then access this active route member variable here. We can then query the params part, which is an observable. We can subscribe to it. And inside here, we will get the object which contains actually our parameters. So let's quickly log that to our console. And you can see now we get an object with person ID, which is the parameter we specified in our routing. And its according value in this case is path1 because we have specified this as our current URL. Like we could add here 1, 2, 3, 4. And as you can see now we get a parameter here correctly displayed in this object. As a result, we could simply go here into our detail components template and say displaying person with ID, person ID. We can add this as a member variable here, person ID. And then below here, we could say this.person ID is equals to data. And let's add it here, person ID. And you can see it gets displayed properly on our template. Now, as always, you can access this in different kind of manners. Like here, we directly subscribe to our parameters observable. However, if you know but for sure that your component gets reloaded each time your route actually changes, you can also access the value via the snapshot. So we could simply do something like this.person ID equals this active route dot snapshot dot params, and then here again indicate the person ID. And that will work as well, just as we expect. So we can say here 222, and it would correctly refresh in our template. Here you can see a very simple routing configuration, which is defined in this people routing module. So whenever our browser URL bar points to this people/path1, our person detail component will be visualized. Now, one of the various ways of passing data via the URL to our person detail components, or in general to our routed components, is by indicating a query parameter. Now, a query parameter is usually added to the browser URL bar via a question mark, and then, for instance, we could say show child equals true. Now, as you can see, even though we specified a different kind of URL by indicating that query parameter, our person detail component still works and is visualized correctly. So that's because query parameters can be added arbitrarily to any kind of URL we define. So we don't have to change our routing configuration for adding those parameters. For reading those, we can simply jump into our person detail component. In this case, we need to get hold of the activated route object, which needs to be imported here always from the Angular router. And then either in our constructor or also in our ng on init, we can then access those query parameters. And we do that by accessing the activated route query parameters, which is an observable, so we can subscribe to it. Let's get that data printed out. Now, if you open up the console, we see here the log statement, and you can see we get an object where the property matches basically here the key in our query parameter, and the value below afterwards is the value we specify there. These are always strings, so regardless of whether you pass a number or a boolean or whatever, these come in as strings, so make sure to always also convert them if you need to. So now that we get the data, we could simply say something like should show children. Let's add false as a default value. Then we can go inside here and say something like div ngIf. And then here below, we obviously need to set this should show children. You can see now it gets loaded properly. And if we change this to false, then it gets hidden, as it also gets when we don't specify anything. Now, as always, if you know that your routed component gets reloaded every time your routing changes, we can also bypass the observer registration and directly access the snapshot. So we access the snapshot, the query params, show childs, and we need to properly assign this also. Obviously, in a real-world scenario, you would then use this information, for instance, to query further data from your server. So as you can see here in this people routing module, I have a path defined which has some static part in front, so people / and then some variable part where the ID is inserted. In my person detail component that gets activated whenever that people route is being hit, I have imported the activated route, and then we use here the params observable to subscribe to it and to fetch out the person ID. In fact, if I open here the developer tools, you can see that the ID is being logged out, the one which we have here in the URL bar. Now in this example here, I have also defined some people service, which has a method getPersonById, and for the purpose of this example here, it directly returns an observable and filters here a static array based on the ID that's getting passed to the service method. Now obviously in a real world example, this would be an HTTP call where you forward that person ID to the server and get the result back. So what we want to do now is in that person detail component, we want to get here an instance of that service. And then below here, we want to filter it. So we want to say this.peopleservice.fetchPersonById. We get here already the ID, so let's store that in a variable. Now this is a string, and so we need to convert it into an integer. We can just do something like that, person ID. And so now here we get back the person. Note this is an observable, therefore we need to subscribe. And we want to display the person somewhere on our template. So let's simply do this.person equals person. And we need to have here a variable. And let's just print it out here below. So now when I do something like that, you can see we get back that person. Let's also adjust that people service to not use the filter here, maybe to use something like the find. So we really get back a single person here. So far that works. However, you can see we get a lot of nesting here. We have here a subscription to that params observable, we fetch out the ID there, and then we subscribe again to that person service here and get out the person detail from there. So since both of them are observables, we can actually leverage the observable operators. So let's rewrite this example a bit. First, we keep the activated route params subscription. And then instead of subscribing, let's use the pipe here from RxJS and then use the switch map operator. So in the switch map here, we would get the params as an input. And we can directly here forward that to our people service. So this.peopleservice.getPersonById. And now we map over the params person ID directly into that call. Let's also import here the switch map from RxJS. And so what switch map actually does is it takes in an observable. In this case here, we get the result of the subscription to the first observable, which is here our root params. And we forward that to that people service, which in turn gives us another observable. And so down here in the subscribe, we finally get the result of that people service observable, in that case, the person. We also need here to remove the semicolon, of course, and then again we can assign here the person which we just got. You can see the example still works, But our code example got much nicer and easier to understand because we get here the params, we pipe it through into another observable, and the result of that observable then gets down here into the subscription. We could even here add further operators which then filter based on the observable returned here from our people service. So here we have a very simple application which uses the Angular routing system. We have here the global app routing module where we have already some routes, for instance the home route which you can see displayed, or the about route. And then we have some sub-modules, which here is the contacts module with its own routings, for instance contact list. Let's give it a try. So we can navigate to contacts list, and similarly also for the people module we can navigate to people list or to specific person actually with a given ID. Now while this of course works perfectly, we definitely want to have some kind of menu which allows us to navigate between those different kind of points. So let's open up the app component HTML where we have defined our router outlet. And at the very top here, let's define here a navigation bar. So here we will basically then add a couple of hyperlinks, for instance for home, which would then point to the home route. Then let's say for the about, which points to the about route. And similarly also for the contacts list. So contacts list, contacts, and then also for the people list. Now if we save this, you can see there appears the navigation bar at the very top, and we can now use that to navigate among our different kind of routes. But rather than specifying these directly, there's actually a directive which gets exposed by the Angular router package, which is called routerlink. And we can use that one to actually improve here our routing experience. So here we specify directly the path, which in this case is home, and pass it ahead to that routerlink. And similarly we can do, for instance, for the about page as well. Now if you refresh, you already notice a different kind of behavior. So here we have at home, we jump at about, and you can see how the URL gets updated. We again also get the new view. However, if we click the contacts part or the people part, the entire page gets refreshed. So that's something also that Angular router handles behind the scenes when we use the router link. So let's also quickly update the remaining parts. And now if we save, we can see how we can navigate here between those parts without any kind of page refresh. Note the very same thing also works here, for instance, for our people list. Now, if we navigate to that people list component here, we can actually add here a hyperlink, just as we did before. We again use the routerlink directive, just that in this case, we specify people as the first segment, and then as the second segment, we directly issue here the people ID. Now, if we save that part again, we can see that we can click on it and the router will automatically update our URL, and we can navigate them back and forth on those various kind of IDs. So the advantage of specifying these segments is that we can specify hard-coded parts as well as variable parts just in between, which get directly data bound to that model which we are processing here in the template. So we have here an Angular app which uses the router to successfully move between different kind of routes when we click those hyperlinks at the very top, which is our navigation bar. However, what is missing a bit here is some kind of highlighting, signaling to the user at which point in the application he currently is. Now in Angular, this is actually quite easy to apply, especially if you use the router link here. So what you can do is add the routerlinkactive directive and specify a CSS class which you would like to have applied. For instance, active route. Now let's copy this over to our remaining routes below here. And now let's quickly refresh our application and switch to the about screen, and if we click here on the inspect button, we should actually see that in our hyperlink the class has been changed to active route. And in fact, if we switch to the people list, you see that the active route has been removed and it has moved to our people button here. What's missing now is to simply go to our styles CSS, which is our global styles for our application, and add that active route class here. And for simplicity, let's simply add here bold for our font. And now you can see how the point of our application gets properly highlighted in the navigation bar. Of course, this could be much more sophisticated if you have some kind of sidebar or side menu with some nice background. And the nice thing is this works also if you directly jump to that route, of course. So in our setup here, we have a people routing module, which follows the routing module pattern here. We have a simple path, which basically specifies whenever that people segment is called, and then a variable part, which in this case is the person ID, then visualize that person leader component. Now what happens inside the component is that we basically in the ng-on-init register to the router params. Then we use here the pipeable operators, and we use a switch map for basically getting here that root parameter, which via that little neat trick here, we convert from a string to a number. And then we basically pass it on to our people service, which on the other side simply returns an observable from a static part here of a set of people. In the end then, if we execute that and specify here people1, we will see how the data gets displayed. If we switch to 2, another person gets displayed, and so on. Now, while this is a perfectly valid approach to basically get the data inside your rooted component, we would like to move that logic, however, outside that component and to move it to the phase where we navigate from another route to this route here. And this can be done basically by using so-called root resolvers. So the first step is to create such a new class. Let's call that person resolver.service, which is a normal Angular service class. So let's paste in here the scaffold. And now what we need to do is to implement a specific interface, which is here called resolve. And for now we resolve any kind of data object because we don't have actually a class here. This is a simple example. But otherwise you would basically specify here like person class or person interface. Now if you implement that interface, we get a method that is called resolve, which takes in a couple of parameters. So let's import all of them from the Angular router. The next step is now to move that logic over basically from our person detail component here. So let's copy this and move it inside here. Next we need to get here the people service. So let's get that injected in the constructor just as we usually do. And then we need to resolve here different kind of parameters. Now, as you can see here, we get already in the resolve method as a parameter the route, which is the snapshot of the current route. So we actually don't need to subscribe to the parameters, but we can directly extract them here. So let's say something like person ID is equal route.params person ID. And again, let's convert that to a number. And now we can simply invoke our person service by giving it here that person ID. And we can remove the remaining part here. Now let's quickly take a look at how that resolve interface is being constructed. So if we take that resolve method here, we can see that as a return type, it expects either an observable, a promise, or a simple value. And that's a really convenient part because in this case, for instance, we return an observable, and so we don't actually have to subscribe here, but we can directly return that observable to that resolve function. Great, so our resolver is implemented, and like with any Angular service, we also need to register it, of course, in the provider section. So let's import it here, person data resolver. And then we need to jump basically to the root definition in the people routing module and register our resolver here. And here we can use the resolve property, which is part of that routing definition. And then we give it a name, which in this case is person, and then pass it in here, the resolver. Now that name here will now be available within our rooted component. So let's go to the person detail. We can remove here actually the whole part because we won't need that anymore. We still need, however, the active route. What we can do here is to say this.activeroute.data, and we subscribe to that. And now inside the data, we have a variable which is called exactly as we specified it in the resolve part of our people routing module. So basically this one here. And this will now contain our resolved person, and we can simply associate it here to our person variable. And so if we save this here and refresh again, you can see it still works. But now the difference is that our data is no more loaded here from our person detail component, but rather it is loaded within our person resolver, which gets called whenever we route from a different route via that people person ID. The Angular router allows us to pass in not only dynamic data via, for instance, a resolver as in this case, but also some static data which happens at compile time. That can be especially useful if you want to configure the rooted component based on different kinds of scenarios. So what we can do is to use a specific property here which is called data, and here within that data object we can simply specify some key, for instance let's say load addresses, and we set it to true. As a result, we can now access that load addresses property in different kind of places. For instance, let's take a look here at that person data resolver, which has been specified here. So we can simply jump in here, and wherever we have that root object, we can simply access the root.data, and in this case load addresses. And let's console out this person data resolver, and let's console out here the load addresses. And if we open up the developer tools on our console here, we can already see that here's the person data resolver, which prints out true as we specified in our properties there. Similarly, of course, we can go into the person detail component and access the same values there as well. So here you can see we already subscribed to the data. So we can do something like console log person detail component and then log out data, load addresses. And you can see how that gets printed out. And otherwise, you simply need to access the snapshot here, which in this case is perfectly fine because the data obviously in this case is totally static and not dynamically resolved. Of course, this is not limited to Boolean values. So in that data property here, we could also specify an entire object that really depends on the use case which we want to solve. So here we have a list of people which we have linked via that router link. So whenever we click on that button, we basically come to the detail page of that person, and we can go back and open another one and see that basically visualized here in the detail part. Now, not always it is possible to actually use the router link and statically link items to each other. Because for instance, in this detail page here, what we would like to achieve is that we change the name, then we click that save button, and whenever that record has been saved successfully, we would like to redirect back to our people list. So in that case, the routing needs to happen programmatically. So whenever we click that save button and we get a successful response from our server. Now let's take a look at that person detail component here. Here we have a very simple input box where we basically use a template variable to get access to that value. And whenever the user clicks that button, we invoke that save method and we simply pass on the name of that person. Now in that save method here, we can actually use the people service and invoke that save method there and pass ahead the person which we have modified in this line here. Now the save method is actually just a very fake method which we have implemented for the purpose of this demo here. So what we do is we grab the person with the same identifier, we set the name, and then we return observable and simulate here some kind of delay, which would usually happen when you call your backend API. Back in our person detail component, what we can do now is to actually subscribe to that observable. And whenever that observable basically terminates, we would like here to redirect back to the people list. In order to achieve that, we need to get an instance of the router injected into our component here. So let's grab an instance by the dependency injector. We get here the router. And now inside our method here, we can actually access the router's navigate properties. And we have different kind of options here. So one, we can navigate by URL, basically indicating a fixed string here. In this case, it would mean the path to that people list. So let's try that out. Whenever I'm here inside, I'm saving the button and I'm coming back basically to the people list again. The other possibility is to use the router's navigate method, which expects basically the same segments we usually give our router link. So in this case, that will be people. So similarly, we enter here, we change the name, then there's the delay, and then we come back to our people list again. We don't actually always have to indicate the full path to our component where we want to navigate, because in our case, for instance, the detail page can be seen as a subpath, as a child basically, of that list path, which is basically simply one above the detail page. So in that case, we can make use of the relative navigation. Simply passing here the relative path is actually not enough, because we also need to tell the router that this is a relative navigation, and this navigation is relative to this route here. Remember, we get the activated route injected here as well in our constructor. So we basically pass on that router access or navigation access property where we specify the relative to property, and we pass in the instance of the current route. Again, if we try this out, if we navigate inside here, we can modify the record, save, there will be the delay, and then we will be redirected again to that people list. So in this example here, we have this list of people, which allows us to navigate to a detail page and back again to that list. Now assume we have some global token here, some query parameter, for instance 123. And what we would like to have is that whenever I click that detail page, we carry on that token along when we navigate from one step to another. Now right now, if you pay attention to the URL, whenever I click to the detail page, that URL gets completely replaced and our token gets lost. Let's see how we can change that behavior. if you take a look at this template here, which generates this list of people, we actually use here the router link and pass on simply the ID of the person which we would like to see. Now, interestingly here, we have another parameter which is called query params, which allows us here to add a token. For instance, we could say ABC here. And if we try that out, and whenever we click somewhere, we see that the token gets added to our URL here, and we get token equals to ABC. We want something different, however. We want to actually take an existing query param and carry that on to the next page. And what we could actually do is, first of all, grab an instance here of that activated route, which we get directly via the dependency injection mechanism. And then what we could, of course, do is here in the ng-init register on that activated route and the query params, subscribe to that, and then one by one expose those values to our template and then basically map them here on our query params directive. Now this is an observable, and Angular templates play actually really well with observables. So what we can actually do here is to directly expose that activated route to our template by changing that private to a public identifier. And then we can use here the async pipe. We can say activated route.query params. And we can use the async pipe to register the observable and actually get that value bound to that query params directive here. Now if we save that and we add here some token 1, 2, 3, 4, and if we click now to the detail page, you can see how that token gets carried on. Now here we have another navigation. So in the detail page, we have basically some code navigation that whenever we click the save button, we use here the router to navigate manually to another route. In this case, we move one level up again to our people list. Now again, if we click that save button, you can see how we lose again that token query param. So similarly, also here we have to give the router the according information and tell him to preserve actually our query params. And this is a simple flag which you can set to true. Now let's again try. Let's add here that token 1, 2, 3. We navigate to the detail page. We see the token remains there. Then we click and we see we get redirected and the token still is there and gets carried on to the next page. So in this application here, we have here a people part, which displays a list of people. And in the code here, you can see how we iterate over that array of people. And by using the router link, we construct a path to display basically the child and the detail of each of these people. So as a result, when we click here, we see the detail, and then we can go back and see the list again. Now, if we take a closer look at how that routing is being structured, we can see that these are siblings to each other. So we have one time the people list which is active, and then if we navigate away, the person detail component will get active as this route gets activated. As a result, these get destroyed and recreated on each navigation. This can also be easily confirmed by adding here an onDestroy callback. And so if we implement that lifecycle hook here on our people list component, for instance, let's move that to the end here and simply do a console log. And let's add the same part to the people detail component. We implement again the interface. We log out here people detail destroyed. And let's move that to the very bottom as well. So if we now open the DevTools and we navigate to a detail, we can see that the people list gets destroyed. And if we then click back, we see that the people detail gets destroyed. While routing this way from the people list to the detail is perfectly valid and in many use cases also desired, we can also have a different kind of structure, namely where the people list remains active, we can click through those items, and then at the very bottom here, the people detail basically gets simply refreshed with the new data as our route up there updates. For that purpose, however, we need to restructure a bit of how our routing is here defined, because now we have basically two kind of sibling routes, while in the new scenario, this needs to be a child route of our people list component. So we can do that by specifying here the children property, and we move that child routing here of our person detail component up in that child property. Moreover, let's also adjust slightly here how the routes work. For instance, let's call this people, which will display in the people list. And then below here, we have just the ID, which means that whenever we navigate basically to /people, the list will be displayed. And then if we go to the ID part, so basically people / and then the different kind of IDs of our person that gets visualized, that component here gets activated. Now, since this is now a child of our component of our list here, we also need another router outlet. So we need to go into people list detail here and specify here a router outlet. Now, if we save, we can go here to our people list, which now has been updated to work just with people. Now, if you click to our list here, you can see how below the people detail gets activated and gets refreshed with the new data. Also note that we don't get any kind of destroy notifications below here. The reason is because both components actually remain active for the whole time of our navigation here. Note that in such scenarios, it is extremely important that your person detail component, which gets refreshed here below, uses the observable mechanism of reading out the data. Because in this way, whenever we update our route, that observable gets triggered, and we will finally then call again our people service to fetch basically the new person based on the parameter which has been updated. The Angular router doesn't allow us to only navigate to absolute URLs, for instance, as we specify here with the router link, because here we indicate that / contacts and then the second segment is list, and so we can navigate among our different kind of views. Now, especially if we take a look at our people list component, you may have noticed that if we click here on people and then on a sub item, that navigation remains active and just the sub item gets refreshed. Now, by taking a look at our inner part here, those router links are actually specified by indicating the full path again. So basically to / people and then appending the person ID. But if we take a look at how that routing is defined, we can see that the person detail component, which is visualized here below, is actually a child of that people list component. This also reflects the path. So both share the first part people, and then basically whenever that second part here is empty, the people list component is displayed, and if there is a / again with some ID, then the person detail component gets loaded. Now we can take advantage of this behavior by actually going inside here and removing that whole part. The Angular router is hierarchical in that it understands that the router link here points to a subchild of that people list component. And so all it has to do is to append that ID of the person, which we are currently iterating over here, to our URL to load basically then the detail component, which gets visualized just below here. So let's save this and try that out. As you can see, it still works by just appending the URL here. This kind of approach is really powerful because you could also do something like that, which wouldn't make much sense in this example. But for instance, we can navigate one level up and then say want to navigate to people and then the person ID again. And even that works just as expected. So in this application, the routing is already configured, such that when I click here, you can see the URL updates and also the component down here gets rendered properly and updated. Now, if we check the network panel and we select here the JavaScript files, let's quickly refresh, you can see the typical Angular files. So we have the vendor files, the main, which contains our application. Here it's actually quite small because it's just a demo application, and then the polyfills and the styles. Now, usually when the application gets larger, that main file increases quite drastically. And so what you want to optimize for is the refresh time of your application. So whenever the user starts the application, should actually start really, really fast and then basically continue to load behind the scenes further modules as needed. And this is what is called lazy loading. So in this specific example, what we would like to do is that the people module should only get loaded once we click on it. So let's configure that. If you take a look at the structure of the application, that people module already resides inside a dedicated folder. We have the Angular module, which in turn registers all the necessary components and services, and it also registers the people routing module, which defines here the path for rendering the people routes. In turn, that people module is referenced here in that app module, and with that basically the entire application gets to know about the routing of that people module. Now, obviously, we need to detach that completely. So as a first step, let's simply remove here that people module. So we should have no hard reference here in our app module. Of course, the application will break in this way. You can already see here when we refresh, now the route is no more known to the application, and in fact our 404 component gets displayed when the people URL here gets displayed. The next step we have to do now is to tell somehow the app module, whenever that people part up there is being shown, it should lazy load behind the scenes that people module with its routing and then activate the according component. And so as a first step here, let's go to the routing module for the application. And now we need to actually tell the app routing module what should happen whenever that people is being displayed. And so here we add that people. And then we cannot actually reference the people module, because then we would have another import of a JavaScript file such as these components up here. And then again, it would be bundled into the main file. Rather, the router has a configuration which is called load children, which allows us to specify a string. And here we specify basically the relative path from that app routing here to that people module. And so we would say something like that, people, then the people.module, and the according class which should be instantiated, which is the people module. So this part is the export from that people module which should be loaded. In Angular, the lazy loading unit is a module, so we cannot lazy load single components, but always just an entire module, which totally makes sense given how the modules are defined. So with that, we have set up the lazy loading part here. Now let's go to the people module. We have still to adjust here something in the people routing, because now the app routing already specifies the first part of the path. So the /people, it will lazy load our people module here together with its people routing, and therefore we have to adjust here the path such that here there is the empty string, which will then load the people list module, and then with the ID, the person detail component. So now let's save. We can see that it gets already displayed here. Let's also check our Angular compiler here. So if we restart here our Angular CLI, we already see that something changed. So actually now we get the main.js file, the polyfills runtime and so on, but we also get another JavaScript file, which is this people module.js. And so the Angular CLI automatically recognizes that whenever here such load children with a string is being specified, it automatically creates a bundle just for those JavaScript files that belong to that module. Similarly, now let's refresh your application. Let's open the network panel. So we see we get the runtime, polyfill styles, and so on. Our main file, as you can see, has now decreased quite a lot. So instead of 40 kilobytes, it's now 26 kilobytes. And if I click now that people link, we will see how the people module gets loaded, which contains the remaining bytes, basically just for that people part of our application. So in this app routing module here, we have a couple of routes defined where the component is directly referenced, and then we have some that are lazy loaded. And especially here the context and the people module, and we can see it here as well as in the browser. So down here, when we refresh the application, we just get the standard Angular files. And when I now click the context module file gets loaded, and same thing also for the people module. Now, when your application gets larger and grows, these couple of files here, for instance, the context module, which here in this demo application is just a couple of kilobytes, may grow quite a lot. And so what happens is that when the file is not yet ready and you reload your application, the user basically doesn't yet have those modules loaded. And so when it clicks the link, it might take a couple of seconds until the megabytes of files are being downloaded for that module. And when you implemented lazy loading, all you want to have is to actually avoid downloading all those megabytes and megabytes of files when your application loads initially, because the user does not yet interact with these kind of modules. So you really want to optimize that time to interactive such that your application starts as quick as possible. But then behind the scenes, we could actually already download the remaining modules lazily, such that when the user then clicks on the modules, they are already downloaded and ready, and so he doesn't recognize this kind of delay. In Angular, this is actually quite simple. So we can go directly to the app routing, where we have also defined here our lazy modules, and where we actually define the root level of our routings. And there, the router takes a second configuration option, where we can specify the preloading strategy, and then we specify the preload all modules. The preload all modules gets imported directly from the Angular router, and with that, let's save this. Now let's go to the home module here, let's refresh again. As you can see now, the files get downloaded, but also already the contact and the people module get downloaded behind the scenes. And so when I click here, the file is already ready and Angular doesn't have to lazy load it at that moment. And so the delay of those lazy loaded modules would disappear completely. So this Angular application has two lazy loaded routes. And both of them are being preloaded automatically at startup by using that preload all modules strategy. This one is already built into Angular, so you can directly import it from the Angular router and just reference it in the configuration of your root configuration here. Now in a large application, however, you might want to control which files are being preloaded and which actually just get loaded once the user clicks that specific link. Now luckily we can totally customize the preloading strategy. So let's create here a new file and let's call that custom root preloader. And here we create a normal class and we implement the preloading strategy. We need to import a preloading strategy from the Angular router. We obviously now also need to implement the interface function of the preloading strategy, which in this case is called preload, which takes as a first parameter the current route of the router. And so let's import that as well. And then a load function, which allows us to basically determine whether to load or not load the current route. And so that here returns an observable. So for now, let's simply return observable of type any and also import that as well. So now you can imagine with that root object here, we can actually determine the current path and based on that, decide whether we call that load function to preload that specific route or whether we delay it to when the user clicks it. Now in my specific case, what I would like to do is to actually apply some kind of flag on my route configuration such that I can specify preload equals to true, and when that is set, it preloads that current route. And we use that data property on our route, which allows us to statically define some configuration property. So let's implement this functionality. So basically I'm saying here when the route.data is defined and that route.data has a preload specified, then we invoke here that load function, which will then preload this specific route. And we also return the value here, which is actually returning an observable. In the other case, we simply return an empty observable, which we can specify as follows. And let's also import here the calling operator here from RxJS. Now, obviously the next step is to go to the app routing. And instead of using here the preload all modules, we import here our custom preloader. Now we also need to define our custom preloader here in the providers section. And so with that, we should actually be set up. Now let's refresh here. Let's open up the DevTools. Let's go to the network panel. Let's go to the home and refresh so that we don't have any lazy loaded route here selected. Then you can see now nothing gets actually preloaded. And that's actually because we specified that it should only be preloaded when that preloading is actually specified on the route configuration. And so now we could go here into our app routing and tell, for instance, that that people module should be preloaded while the contacts module should just stay there and only be loaded when the user clicks on it. And so we use that data property and we specify preload equals to true. Let's save again. Now you can see that the people module gets preloaded, just as we assumed, and the contacts module in the other side only gets preloaded when we click on it. So usually in a real-world application, you might want to guard access to specific routes. So certain users might be able to enter, for instance, the contacts route, and other people might be able to enter the people route. Or even more differently, for instance, the home contacts routes are open routes where you can access even in anonymous mode. However, if you access, for instance, the people route, you have to be logged in. And so in order to demonstrate how we can basically protect certain routes in Angular, I've implemented here a very, very simple Angular authentication system. And so we have here an authentication service, which works very simple. It has an is logged in flag, which is by default false. It has a method which can be queried whether the current user is logged in or not. And then we have a login or logout method, which simply set that Boolean flag. Again, in a real world application, you would probably have here a verification for a token. You would call the backend to see whether there is an active session and so on. Moreover, as you can see here, we have that login and logout button here at the root component. So if you go into the app component, here we can see that in the template, I'm simply switching that on and off. And when you click those buttons, then in the app component code here, I'm invoking the login or logout of our authentication service. Great, so let's go to our app routing module. And let's assume we want to guard that access to that people module here. And for doing so, in Angular, we can use the canActivate property here on the route configuration. So let's go and implement such a guard. First of all, we need to create here a new class. Let's call it authentication guard.ts. And so this is actually a normal Angular service. So we need to inject here an injectable and create a class. Let's call it outGuard and implement the so-called canActivate. Make sure that the import is correct, so we can import that directly from the Angular router. We also need to import here the injectable, and then we can implement here the interface, which is canActivate, which takes the route, which is an activated route snapshot, and then also the current state of the router. And as a return value here we have Boolean, and so for now let's return just false. Now, having that route snapshot state here, we could actually again query that route configuration, and for certain routes based on its path or some other properties, we could allow people to enter or not into that current route. However, in our specific implementation, we want to query the authentication service, which we have seen before. So we can just inject that here just as we do normally. And we might also need an instance of the current router. So let's import that also from Angular router. And then we can start with the actual implementation. In our example here, this is quite simple. So we can say this.out service.is logged in. And so if the user is logged in, then return true, so he can actually enter that route. Otherwise, we don't want to let him enter, and therefore what we do is we use the router and navigate directly again to the home route. And we also return here false, such that that route doesn't get activated. So with that, our implementation should be concluded. What we have to do is to register it actually also in a providers array. So we can register here our outGuard. And finally, once we have registered it here in the providers array, we can also reference it here in the canActivate array. And so now if we click that context part, it works without any problems. If we click that people link, however, we get redirected to the home automatically. Now let's log in. Let's try again. And now you can see we pass basically that guard and we enter successfully into the route. Most importantly, this also works when a user directly modifies the URL up here. So if someone goes here and wants to enter that guarded route, he would refresh here and would automatically be redirected to home again. Also note that if you have a route with children, for instance, if we would have a normal route, let's say up here, and you have load children below here where you have to find other routes as a sub route of this about, then you may also want to take a look at the canActivate child function, where you can pass in the same outGuard, just that you don't only have canActivate but also the canActivate child, which can have basically the same implementation, however. So here I'm having a routing configuration where we have a people module, and that people module uses a canActivate property here and uses the implementation by this outGuard, such that users which are not logged in won't be able to enter that route. So if the person clicks that people route, it will not be able to enter and will be redirected automatically to home in case the person does something like this by specifying the people route in the URL. Now, if you pay close attention, let's also refresh this again. This people route is actually a lazy loaded route. So what happens is that when I'm not logged in here, as it is currently the case, and I click that people route, you can see that the JavaScript file gets loaded over the wire, but then we are not able to actually load the people module because we are not logged in. So the point is that in this case, it's totally useless to load that people module. Now, Angular for that purpose has also something that is called canLoad, which takes the same syntax, so we can directly reuse that outGuard which we have specified. The only thing we have to do is to also implement here the canLoad interface, which we again import from Angular router. Let's also implement the actual interface function, which returns here again a Boolean. So let's use that Boolean here. We get again a route configuration and URL segment in this case. For our specific implementation here, we won't need any of those. So we will actually use the same implementation. And for that purpose, let's extract that into a known function. And again, here we copy this over. And in this way, we can now reference the function from both our canActivate and also on our canLoad function. So now let's save both of these files. Now, if I click that people module, nothing actually happens. Also, the file doesn't get lazy loaded over the wire. Now let's log into counter check. If I click now, it gets lazy loaded and our module gets properly visualized. So in this application here, I have a list of people. Whenever I click here, a form opens, which allows me to modify that person and to save it again. Now I've also implemented here some mechanism that visualizes me whenever I have unsaved changes. This is implemented very naively and very simple. I have here basically the form. Here you can see that is dirty flag is being visualized, and this is being calculated by simply registering on the value changes for that name field, which represents here that field of the name of the person. And whenever that changes that, we verify whether that name is different of the current person name. If it is, we display here that is dirty true, otherwise dirty is false. Also, if I change here, the dirty flag gets set to true, but then I save it, which is down here. So basically by submitting the form, and then I manually reset the dirt to false again. Now, usually in a real world application, what you have is that whenever you change this here, and then you have unsaved changes, basically, you navigate to some other view, you should actually be notified, telling you about the potential data loss because you didn't save the changes before leaving. So the Angular router allows us to implement the so-called canDeactivate guard. So let me create here a new class, canDeactivate.guard.ts, and let me just paste in here some predefined template. This is a normal Angular service. I implement here the canDeactivate, and the canDeactivate usually takes an instance of a component. Now we could generalize the part of having some kind of dirty component concept as an interface and implement it here. However, in this specific example here, I'm implementing directly the person detail component. Let's also import that. And then we have to implement the canDeactivate function. And the canDeactivate function takes first of all the component, which in this case is a person detail component. Then we have the current route, which is an activated route snapshot, and the current state of the router, as well as the next state. And this here returns a boolean, an observable of a boolean, or even a promise. Right now we just need a boolean, so let's implement it that way. Alright, and now that we have the component that gets passed in here, so the component instance, we can directly query it. So let's first of all determine whether it is dirty, and we can directly say component dot is dirty. So we basically access here that property of our component, and if it is dirty, we want to actually inform the user. And so in the case, we do simply a return confirm you have unsaved changes, and this will return then a boolean value, so we can directly return it. And otherwise we can simply leave that form, so just return true, because we don't have any dirty changes. Now obviously we need to register that canDeactivate dirty component guard here, and we directly go to the people module. We have here the providers and we register it there. And then we have to also go into the people routing module, and here on that people detail component, on the person detail component, we specify the canDeactivate property. All right, now let's navigate to that people module. Let's go here to some person. Let's modify that such that we have unsaved changes. Let's click on contacts. Now you can see you have unsaved changes. Do you want to proceed? Yes, I want to proceed anyways. So it will let me proceed out of the people detail component here. However, if for instance I have unsaved changes, I want to navigate away and I click cancel, I remain inside here, so I can save those changes and then I can navigate away without any problems.